Hello, what's the question today? Okay, here is a prism with the dimension is 9620. And the question today is if you can only stay on the surface of the prism and then you like to go from point A to point G, what is the shortest path and what is the shortest distance? Okay, so we have to get the path, then we can find the distance. But how do we know which distance is shortest? So because we from point A to G, we have so many different paths we can go. Say for example, let's get some possible paths. Okay, let's say from point A, we can go A to B, B to C, and C to G. Or we can go from A to B and B to G straight away. This looks a bit shorter, right? But of course, we can go from A to somewhere here and then go to G. But we can also from A go somewhere here and then go to G. But where you landing, you get shortest. But of course, you can also go from A, you go zigzag, and then go to G. But of course, you will see, oh, this is silly. Because zigzag definitely gonna take longer, straight will be shorter. Right, this is the point. So we have to go straight, then we know that's gonna be a shortest distance. But the point is from A to G, they are in two different planes. You can see the blue plane and the red plane, they turned. So you cannot go straight, you have to turn. Then that's why the problem is. So I'm thinking reshape, the prism reshape it. Keep the same dimension, but reshape, make them flat into one plane. Then from there, we can find the shortest route. Because we can go straight if we get one plane. Okay, so then how do we reshape this? We have two different ways to reshape it. So let's have a look which two ways. So one way is you can go flatten the blue and the red face like the left one. Or you can flatten the blue and the white face like the right one. That's two different ways you can flatten it. And then you can see the shortest route possibly is from A to G is these two routes. You can see. Could be this one. Let me get your A to G. That's your shortest route. You can see that's one possible. Or you can go from here to here. That's another one. But we don't know which one is shorter. That's two possible. Well, let's work it out. So because it's go flat and the dimensions are there, so we can do the calculation. Do you know how to do the calculation? Of course, you know, right? We're going to do Pythagoras theorem. Okay, so the AG here could be equals to square root of 15 squared plus 20 squared, which equals to 25. Or here AG could be equal to square root of 26 squared plus 9 squared. But that approximately gives you around 27.5. So this is not a good one. This one looks good. 25. Okay, so that's the shortest distance. Then what is the path? So we need to work it out where you landing on the BF. Where? Okay, so let's make you landing BF at, let's say, point M. I just make a point M. So we need to find what BM is. So let BM equals to X. So we can see in these two triangles here, I'm going to make a little bit thicker, will be easy to see. We have triangle ABM and a triangle AGC. These two triangles are similar triangles, right? We can see. Then we can use the ratio to find what is the X. Very simple. Okay, let's do it. So X over 20 will be equals to 9 over 15. So from there, we can find that your X is equal to 12. So which means if you're landing on the BF, but 12 units from B, then that will be the shortest path.